Welcome to CSE Core Concepts in the series of Searching and Sorting. In my earlier videos, I have discussed about the various types of searching, that is linear search and binary search. Now I am going to start about various types of sorting. But before we can actually start with the sorting algorithms and describe them each of them, so I would like to discuss about a few characteristics or few elements about sorting. So broadly categorizing sorting, there are two types of sorting are there. One is internal sorting and another is external sorting. So let us understand what makes these as internal or external. In case of internal sorting methods, they use only the primary memory and they process a small list because as they are working using only the primary memory, they will be able to process small list due to memory constraints. The various types of sorts under this criteria are selection sort, insertion sort, which we are going to discuss in our upcoming videos. Now, another type of sorting is the external sorting, where the algorithm uses the secondary memory. It performs some temporary sorting and the currently sorted data is stored in the primary memory, but the bigger list unsorted data is stored in the secondary memory. The sorting methods which are based on merging, like you divide, then you sort each of the lists, then you merge the list, such as merge sort, they come under the category of external sorting. So let us start with the first type of sort, that is a selection sort. Now you can see here some code snippets I have written. To understand this, first we will take an example. Consider an array having 9 elements. The values are in an unsorted order. Now you can see in this code snippet there are two loops. That means you will have a I loop which is iterating from 0 to n minus 1. So if the array index is starting from 0, it will continue up to 8 because there are 9 elements. And the second loop, you can see the inner loop is starting from I plus 1. That is the next position from the I to n minus 1. Now leaving the first element, ith element, you are going to search for the smallest element from the subarray, and if you can find the smallest element from the subarray, we will swap it with the ith element. So if you are considering the first position, that is 0, so if your I is equals to 0, the j loop will start from I plus 1, that is from first position. From first to eighth position, we are going to look for the smallest element, and which if the smallest element found is lesser than the zeroth element, then we will swap it with the zeroth element. And we will go on doing this till my outer loop, that is I, is up to n minus 1. So let us, for this array, initially my I is equals to 0, and I will go up to my j, that is, if I want to find out the smallest element. Okay, so I will start j from I plus 1, that is from 1. At the first position, the value is 70. Then comes 75, 80, 50, 60, 55, 85 and 45. From the index element 1 to 8, that becomes my subarray. And in this subarray, the smallest element is my 45. Right. So 45 is smaller than 65. So we are going to swap the positions of 45 and 65. So in the past one, you can see 45 becomes my 0th element and 65 becomes my 8th element. Now it may not be that that 65 is the largest element, but gradually when we will go on doing such a process, we can place 65 in its appropriate position. So now my I is my 0, right? At I is equals to 0, my j is currently starting from j plus 1. Okay. Next time I will move, iterate through I. So I will now become my 1 and j will start from I plus 1, that is 2. From the second position to 8th position, it will search for the smallest element. So here the smallest element is 50, and of course it is smaller than your ith element, that is 70. So we are going to swap a j and I, that is Now in my second pass, 50 is coming in the first position and 70 went to the fourth position. Now again I will repeat my loop. I is equals to 2 now. So j has started from 3. So from 3 to 8, j will continue and it will find out the smallest element from this subarray, which is now 55 and it is smaller than 75. So in this case, we are going to swap 55 and 75. Now next time I is equals to 3 and j starts from 4. From 4th to 8th position, 60 is the smallest element, that is at 5th position, and 60 is smaller than 80. Hence, we are going to swap 60 and 80. So eventually with each pass, you can understand that the elements from the beginning are getting in a sorted order, right? Next is I is equals to 4, of course, that is 70. And from I is I plus 1, that is from 5th to 8th position from that subarray, 65 is the smallest element. So 70 and 65 will be swapped. And then next is your 65 is coming, right? Next your I is equals to 5, right? So j will be from 6, 7, 8. Among 6, 7, 8, you have to select which is the smallest element. 70 is the smallest element among these three. So 70 and 80 is going to get swapped. Fine. So all good through till 5th position. Now I is equals to 6. And among 7 and 8, who is the smallest one? That is, smaller one is 80. So 75, 80. But here, do we require to swap? No. Because 75 is already smaller than 80. So we won't swap 75 and 80 here. Then I is equals to 7 and j is equals to 8. And of course 80 is smaller than 85. So they are going to get swapped. Understood? Now here you could understand that two loops were working. One is the outer loop, that is I. So I was moving for all n elements. J is actually also moving for all elements except the first element, right? So two loops when they are going, as I discussed in my video about time complexity. If you have missed that video, please go back and go through that video because it is very important to understand how the time complexity is computed. So the outer loop is going for n times. The inner loop is again going for n times. So n into n, that is n square. So the time complexity of selection sort is n square. So in my next video, we are going to understand about the another sorting algorithm. Please don't forget to like, share and subscribe to CSE Core Concepts for such informative videos. Thank you.